now we're going to go to Locomotion. So I'm going to hit Tab and create mocap biped 3. For this example and teaching Locomotion, I'm going to just be using a rig from Houdini, this mocap biped 3. You can dive inside it and see that, it's got bones and it's got a geometry object where the deformations take place. The reason why I'm going to do this is because it's simple, it's straightforward to use. Everybody already has this information. It comes by default with Houdini, and we can kind of get up and running. I'm going to make a separate section on importing FBX and importing USD and importing from LOPS, so that you have access to that. In addition to importing, I'll also talk about export. So those will be separate videos, and you'll be able to look at those, the ones that are relevant to you and of interest to you. But for the time being, I'm just going to use this kind of mocap biped 3 rig. It's convenient and easy to access. So first thing I'm going to do is take this guy and rename it to walk. And at the moment, it's change to animation type to walks and turns. We'll use the default of walk L001. So if we play this back, one thing you'll notice is when it hits this loop, there's this pop. That's okay. We're going to leave this in here on purpose. One of the nice things about Crowds is it has ways of adjusting for this and cleaning this up. So that's what we'll handle that later on. But just to make sure that it's there and it's there on purpose. The other thing we're going to do is turn off in-place animation. So there's actual locomotion. It's actually moving or shifting in space. And then I'm going to make a copy of this. I'm going to hold down the Alt key and drag, rename this to run, and change it from walks and turns to run. And we can just use the default clip there. So, and we can zoom out, take a look, verify that this is working as well. Great, we're in good shape. Okay, so next thing we're going to do is we're going to go over to our shelf tools here, Crowd Shelf Tool, and we're going to make an agent out of this walk cycle. So I'm going to click, and you see we have options for FBX, USD, and LOPS. At the moment, we're just using a character rig, which is fine, but just be aware that those options are there. And I'm going to change this to walk, hit OK, and we're off to the races. Okay, so we have our mocap biped 3 set up. The next thing that we want to do is add a clip to our setup. So we come up here and go add clip, and click on our agent, hit enter. And I'll just pick the rig. So I'm going to choose run, name the clip name to run, hit OK. And there we go. Okay. So we have our walk and our run clip, which is what we're going to use for this example. We're going to keep it fairly simple. And great. So there's a couple of things that I'm going to show you here. We want to, now that we have these clips in here and we have in-place animation turned off, we're going to go over here to this loads clip section, and there's this option for convert to in-place animation. And we want to have that turned on for both the walk and the run cycle. Okay, so we get an error, which is totally expected. But the first thing I want to do is kind of explain why we're turning on convert to in-place animation. This might seem a bit confusing. We just, made a point of turning off in-place animation up here on the rig. Why are we, turning this on now in this load clip section? What's the motivation? It seems kind of contradictory. And the reason why we're doing this is when we convert to in-place animation, we're doing two things. We're bringing the clip, back to the origin and calculating it at the origin. But the other thing we're doing is computing the transformation. So where the agent is, or where the rig is actually moving through space. And that's kind of being isolated to a separate channel. And that information will be used by the simulation when doing locomotion. So that's why that's there. So we get an error, and the error says missing or bad locomotion null for in-place animation. So what this means is we need a frame of reference, or like the root of the hierarchy, so that this load clips node can calculate the locomotion. So let's come up here to locomotion node. I'm going to hit this, and I'm going to choose the hips of my skeleton, which is basically like the root of the skeleton. And we can come back up here and go to inside the rig. I'm going to hide other objects in my display. And you can see that, yes, the hips are actually the root of, this hierarchy. So great. Okay. So back to mocap biped setup. We've chosen the hips as a locomotion node. You also have this option for locomotion orient. So this is kind of going to compute the transformation of the agent based off these, the location of the hips. But we also want to use something to kind of calculate the orientation in terms of if the agent is, turning or something like that. This is information that we can use. So I'm going to go to this drop down, and I'm going to pick right up leg to right leg. And this is basically like the femur bone on the right leg. And this is great, like a good bone to use in terms of computing orientation, because it's usually facing in the direction that you're going. So that's why that's there. Okay. Some other things to kind of keep in mind, and I'm not going to adjust them now. I'm going to adjust them later in the video. I'm going to tell you that you need to adjust them, but I'm not going to adjust them till later, so that you can see what happens when you do something wrong, and you kind of have an understanding of how to fix it. One of the things that you'll need to set is this kind of start and end frame for each of the clips. And the reason why is because if you don't, your kind of clip will, at the moment, it thinks that the clip is on 240 frames long, which it isn't, right? The clips stop at like maybe 25 frames, and in the run's case, like 17 frames. So, but it'll still think that all those frames that come after, it actually stops moving, are still relevant, and will try and use those as a clip, and you get undesirable results in your simulation. But I'm going to have this, I'm not going to adjust this now, I'm going to adjust this later so that you can see what it looks like when things are working improperly. Okay, so that pretty much covers the setup section. Oh, actually, that's not true. There's a couple other things that I want to set up. Collision layers, so for ragdolls. So let's come over here and hit the collision layer. Select agent to add collision layer to, press enter to complete. So, it says no agents were selected. Did I do something wrong with my selection? Let's try it again. Collision layer, select my agent, enter. There we go. Okay, so this is basically creating the collision layer, which is kind of these collision objects that will be used for ragdoll. If we switch to wireframe, we get this. And you'll see that it already has this by default. The reason why it has this by default is it's using Houdini's own capture regions. So rigs in Houdini have bones, and they have associated capture regions, and that are used to deform the skin geometry. There's a deform node. So basically, by default, because we're using a Houdini rig and we have these bones, it's using those bones to kind of define the capture regions. So these capture regions are kind of used to deform the skin, and now these same capture regions are being used as defaults to kind of set um, these capture regions. So if you were importing from FBX or USD, you probably have to set this up manually. But in this case, it's done for you. Yeah, so something to be aware of. Yeah, and here you can see there's the transformation name, and then there's the shape type in terms of you have options in terms of box, sphere, or custom shape. You can use custom shapes as well. And these are kind of the parameters for that. And you can see that these are defined for all of the relevant bones. Okay, great. The other thing that we need to do is we can define configure joints. So let's do that. Click on this. Select agent whose joints you want to configure and press enter to complete. So select that, hit enter. And then we get this. So, and then these are regions that are, these kind of define, these are cones that kind of define the motion or the range of motion that these joints are allowed to have for ragdoll. And there's a convenient little node that gets dropped down here so you can test with it. And I'll just grab this and let it drop. Groovy. Okay, so these configure joint regions, I believe by default it uses, well, let me click that. So there's this button here that's really nice, and basically it looks at the motion in all of your clips of the bones and kind of uses that as a kind of guideline for setting, the range that these bones can move in. And you see it defines these cones, and you can come in here and grab these cones and actually start adjusting them. So you have control for that. Yeah. So this kind of create limits for collision layer is kind of useful for doing that. But you kind of, it looks at all the clips and it looks at the kind of range of motion that's being used in those clips, and it kind of gives you these cones. And these are limits essentially for your ragdoll physics. So we can come back here and test again. There you go. All right, groovy. So we have that. One of the other things that I should mention that we can make use of here before we kind of end this video, it's a nice transition into the next one, is there's this agent prep, these other nodes. So you have the clips, which we've loaded, which basically make your agent definition. You have the option of writing it to disk. And then, you have, once it's written to disk, you have the option of loading from disk. Then you have this agent preparation node, which, is setting up, is basically setting up which bones should be associated with which part of the body. So, upper limbs, lower limbs, torso, ankle, knee. So you have this kind of setup because we're using, the kind of mocap biped 3 rig. All of this kind of gets fed in here automatically for us, which is convenient. If you are importing from, FBX or USD, chances are you're going to have to set this up by yourself manually. But once you do, you can, save this as a preset. And then you'll always have it, and you can just use that for whenever you need to use the agent. And you can save presets over here. So there's save preset. Okay, so one of the things we're going to do over here is create a foot plant chop network. So you can do that by clicking on this button. It creates a foot plant chop network, which is this node over here. And this is used to give information on foot planting. Basically, what it does is it looks through all of the clips and it does a calculation. By clicking this node, you create this chop network. And I'll dive into chops just for a moment. And chops networks is basically a motion editor. And what it does, I'll switch over to the motion effects view for a moment. Display. So what it's doing is it's basically doing a computation, and it's computing, looking through the clip, and it's computing when the feet are on the ground, or what it thinks is on the ground, and static. And this channel information that it's using is going to be used by the simulation to lock the feet to the ground when the simulation is actually running. So you can see we have a bunch of nodes. We have the agent, and then we have the foot plant chop nodes, and they're all being fed into a merge. You can see that we have a different set for each state that we're working with. So walk, run, and then there's one for the rest state as well. You really don't have to be too concerned about what's going on in here. Usually you just have to press this button and it works. Sometimes if you change your agent or you add new clips, you'll need to recreate the network and then reload the clips, just to make sure that you got like the best or current foot planting data. But other than making it, you really don't have to worry about it too much. Just so you have a bit of an appreciation and understanding of what chops is, I'm going to show you this little example. So the chops context in Houdini is the motion editing context. So this is a very simple example. Here I have a sphere. It's just stationary. Then I put down a transform, and I'm animating the sphere's motion with a random function, and I'm basically changing the seed using the frame to change the seed. So that means every frame it's going to return a different value. And if we kind of play forward, we can see that it's very erratic in its motion. All right. Okay. So say we wanted to smooth out this motion. Say we, gotten data from some sort of motion capture rig or something like that, and it was noisy, and we wanted to reduce some of this noise. Well, we could drop down a chop net, and inside of the chop net, I'm going to switch over to the motion effects view. There's this operator called a geometry operator, and what it's basically doing is looking at the SOP, this one called two chops, and it's bringing in the position information of the point. In this case, it's a primitive sphere, so there's only a single point. So it's bringing in that information, and you'll notice it's bringing in the position for the entire frame range. It's got the position in X and Z, but the position in Y is where we're getting most of this behavior. So we have this option to filter. So I'm going to filter out the channel. And what it's basically doing is it's smoothing out the channel. So I can adjust the filter width, right? I can adjust the effect. And it basically smooths out a really noisy curve. And this is what you get. So chops is used basically to manipulate stuff like this, which is basically animation over time. And this is what the foot plant chop network is taking care of. Okay, So let's go back up here, and we've smoothed out the animation. Now what we can do is we can take that information that we computed in chops and point this channel node towards it and bring it into that information back into SOPs and basically modify the position. So now the movement is much smoother, and I can template the original animation, and we can kind of see a comparison of the two. All right. So this is a very brief and very simple introduction to chops, but the idea is just to kind of give you an idea of what it is, so that when you're creating things and you're using that foot chop, the foot plant chop network, you at least know what it is, and you kind of have a bit of understanding of the context around it. Okay, welcome back. Where in the last video we talked about the foot plant chop network, and I kind of gave a brief introduction as to what chops is, just so you have a little bit of context. This kind of concludes the setup portion of the agent. So I'm going to come back up here to mocap biped setup. And the next thing we're going to do is, so we've taken care of the agent, clips, collision layer, configuring joints. The next thing we want to do is populate. So in order to populate, we need something to populate on. So let's make some terrain. So go hit tab, type in geometry, and rename this to terrain. And let's dive inside. I'm going to hit tab and create grid. I'm going to change its size to 100 by 100. And I'm going to drop down a Vex mountain after this to kind of add some noise. Oh, sorry. Mountain. It's not called Vex mountain anymore. Showing my age. All right. So here is our mountain operator, not really doing too much. I'm going to increase the height to 3. We can see it's doing something. It'd be nice if we had some more detail. So I'm going to add some rows and columns. I'll do 100 by 100. And okay, so now we kind of have something. It's too high frequency, the noise, so I kind of want to lower this. So I'm going to come over here to the scale attribute in the mountain and just kind of drag this down. Maybe need more than that. You know what? I'm just going to type 0.1. Never mind. Silly me. I'll just go to the element size and change that. Then it does it uniformly, right? Or it should, and it's not. Was doing it in the wrong way. My apologies. Okay, so here we go. We have some terrain. I'm going to lower the frequency even more. Just going to get nice gradual slopes. So uneven ground is essentially what we're going for. And then I'm going to make a null node. And I will name this terrain. Okay, great. So this works. Let's source our agents onto this grid. This is the terrain we're going to be working with. Okay, so you come back over here to populate, and it says select agent setup object, if any, and press enter to complete. So this is our setup object. I'm going to hit enter, and then it says now select terrain points object for crowd placement. So and then press enter to complete. So I'll select the terrain, and hit enter. And what happens is we get a crowdsource object gets created, and it puts us inside it. For the time being, I'm going to change the display to ghost other objects so we can see the terrain. And if we take a look, we have our agents and they are placed on the ground. Okay, I'm going to do a couple of things here. I'm going to hit D, change the background to dark. Just find it makes it a little easier to see what's going on. And there we go. Okay. So, and the crowd agents have been placed on the ground. Fantastic. A couple of things though is this is using the entire piece of terrain to put these agents down on. I want them to kind of start over on this edge of the terrain. So let's just kind of talk about how we could do this. Well, firstly, let's talk about what nodes have been created here and what we're working with. So over here we have, this is the agent we're reading in, right? And this is the terrain we have over here on this side. And then we have our crowd source. And this is basically sourcing the agents onto this piece of geometry. We have controls here for number of agents, so I can change this to 100 or 1,000 or whatever you like. There's a random seed control. Lots of different controls here in terms of placing agents. One of the other things you can do is right now we're feeding it geometry. But if you want like really precise and fine control of where you want to put your agents, you can just drop something down that has points on it. So I'll make, in this case, I'll just temporarily, I'm going to make a line. And I will make it 10 units in length. And by default, it's going up the y-axis. I'm going to change this to go down the z-axis. All right, so, and I'll hide the terrain for the time being. So here's our line. It currently has 2 points on it on either end. And if I plug this into the crowd source, what it's going to try and do is instance or have 100 agents along this line, because it's basically scattering along this line. So in my case, what I want is I want an agent for each point on the line. So there's currently like 2 points. I'll just increase this to maybe 6. So I need a way to, I want basically each agent to be instanced to a specific point. So what I can do is drop down this add operator. And the add operator has this handy little option for deleting geometry but keeping the points. So you can see there that we have those points, right? And now if we feed that in the crowd source operator, it ignores the number of agents when it sees that there's only points coming in on the right-hand input, and then it'll basically copy the agents to those points. So you have a lot of like precise and fine control that you can use in terms of placing these agents. So yeah, it's something to kind of keep aware of. But for the time being, I'm going to come back up here and look at what I got with the terrain as this kind of second input. All right, so yeah, this is good, but not exactly what I want. What I want is I want my agents to be sourced over on one side of the geometry, and rather than the entire grid. So that's easy enough to do. I'm going to go to my terrain input, and I'll just click on this arrow, bring myself over, and I will branch off from what we have here, and I will take a clip, and I'm just going to clip off part of this terrain. So actually, I'll just connect it upstream here. So a clip is just this handy operator. It defines a plane and it'll delete any geometry above the plane, or keep the geometry above the plane but delete the geometry underneath it. Or you have the option to invert that if you so choose. Very handy for a number of different operations. This one, I'm just going to have it point down the z-axis, and then I'm going to move it back. And I'm going to cut the primitives below the plane, so I just have this narrow strip. And then I'll drop down another null node, just name it source. Groovy. All right, so let's go back up here, and we will change our terrain input from terrain to source, hit accept, and now all our agents are being created in this kind of band here. And I'm going to reduce the number of agents just so this not quite so crowded, and we can see what's going on. Okay, groovy. One of the things I'm noticing is that it looks like the state that they're starting off in is this run state. I want them to start off in the walk state. So I'm going to go back up to mocap biped 3 setup, and where it says load clips, there's this set current clip, and I'm just going to change that to walk. Groovy. Okay. So crowdsourcing, yeah. Okay. So, yeah, we got this set up, and we're in pretty good shape. So the next thing we can kind of jump on is setting up the simulation. So, oh, actually, I'll mention a few things here. Just to kind of let you know about sourcing. There's this randomize tab, which is great. It allows you to randomize a bunch of things. So at the moment, we only have a single agent coming in on this left-hand input, but we can have multiple, right? And you'd want that because chances are if you're doing a crowd sim, you don't want the same agent over and over again, right? You want different types of agents. So there's this control for randomizing agent primitive. So, if I had like 3 different types of agents, I could say, mocap biped 1, and then mocap biped 2, and then kind of 3. And then I could, control the weighting. So if I wanted more of mocap biped 3, I could kind of increase the slider and it would change the distributions. In this case, I only have 1, so it doesn't really do anything. Randomizing initial state, you can do this as well. Works kind of in a similar way. Turn this to run, and now, the distribution. Some are going to be walking initially, some will be running. Again, you can change the weighting. So for this example, we won't use it. Clear and randomize initial state. Randomize clip time. This is useful, and it's something we will use. So this is basically where in the clip it should be starting from. So I'm going to, change this random offset to say 1, because I happen to know that the walk cycle is like, this is the time in seconds. So, or the maximum time in seconds in terms of how it's going to be offset. And I know that the walk clip's like 28 frames, so, slightly larger than 1 second, but for ease of use, I'll just put 1. But now we have, some randomization in terms of start time. Then there's, options for randomizing, scale, initial velocity, randomizing heading, etc. Yeah, so there's also this concept of agent layer. This is not something that I'll be discussing, but you can do things with by creating agent layers where you can have an agent like holding a hammer or having like different types of wardrobe. And these, so you can define these various layers, and you can use this like randomized current layer to kind of switch between those. If you want more information about that, I would suggest going to SideEffects' website, taking a look at the tutorials in the video section, and you'll find some information on doing that. But it's out of the scope of this course for the time being, anyways. All right, welcome back. We're going to talk about setting up the simulation for Locomotion. In this In the previous video, we were talking about the crowdsource object node and the populate train tool, or the populate crowd tool, and setting that up. So we've gotten that set up. We can go on to the next state, which is the simulate. So fairly straightforward. Oh, I should mention also, just in terms of crowdsourcing, there's this option for painting density. So you can click on that and then actually paint on your source where, if you want your agents in a specific area. It's another way to control where your agents get placed or sourced. So yeah, let's talk about simulating. The first thing that I want to do here is I'm going to go into my terrain object, and currently we have this kind of source geometry being displayed. And I want to change that back to this full terrain. And the reason why is because we're going to be using the entire terrain for terrain adaptation and foot locking and what have you. So we want to make sure that the entire terrain is visible, so that we aren't just selecting a small piece of it like the source. We're selecting the entire terrain for adaptation and foot locking. Okay, so simulate. Fairly straightforward. We come over here. I've selected the crowdsource object, and I click on the simulate button. And then I get this option. It says, select the states to add to the crowd simulation. So I'm going to select run, walk, and ragdoll, and hit accept. Okay, great. So what it creates is this dot network, and the simulation is what's contained inside it. So I'm going to walk through a few more setup steps, and then we'll kind of conclude the video, and then I'm going to move on to a kind of explanation of what DOPS is. But I just want to kind of get through this setup portion here. So we have the sim, and we can dive inside it. I'm going to hide other objects. Just press play. So a couple of things we're noticing right off the bat is you see here the agents start walking and then they kind of freeze in place. Well, if you remember from when we first started in kind of the Locomotion setup, back up here on the mocap biped 3 setup, I mentioned that there was, in the load clip section, that there's a start and end frame parameter that we have to set for each of the agents. And if we don't, we'll run into a problem. And this is the problem you end up running into. So it'll reach the end of the clip, but as far as the setup's concerned, the clip lasts 240 frames, not the 28 frames in terms of the walk cycle. So it just keeps kind of gliding forward like this, which is not really what we want. So we need to change this. So the first thing I'm going to do, I'll turn off the display of the crowdsource and the train. I'm going to come up here to the walk and just check out this walk rig. And yeah, so I believe it's 28 frames. Let's just double check. 25, 26, so 26. It looks like there's a kind of really nasty bump at the end there, so I'm going to just say 25. Yeah. All right, so dive inside here. You know what, I'll say 26. We'll deal with that nasty bump in another video. And then let's take a look at run and see how long run goes. So let me turn off the display of walk. My apologies. So 15, 16, 17. So come back into the setup, change this last frame to 17. So just a few, I'm going to stop to make a couple comments here about pipeline. Well, actually, let's go back to the crowd sim and first of all verify that everything's working. So we see we have this kind of orange line. That orange line is, represents a sim that is now longer kind of defunct. We can reset the simulation on the .NET. There's an option to reset the sim. So we can just click on that and everything gets cleared. And we can come inside. And there we go. Okay. So if we take a look at the sim now, we got a little bit of bump in the simulation. Yeah, there should be a bump where it transitions over. That's okay. We'll fix that later in another video. But for the time being, what we have is decent. All right. The other thing that I want to do is right now there's no terrain adaptation. It's just kind of being sourced and walking straight forward. See, there's the terrain has not been specified. So we need to add the terrain. So I'm going to come back up here to object level, and I'll turn off the display for the run. Maybe turn on crowd sim, and I'll turn on the display for the terrain. And yeah, we can double check that this is not, that no adaptation is actually taking place. If we kind of play forward here, you should see they just kind of walk out onto space, right? So this agent here is just kind of walking onto nothing. Okay, so let's take a look at fixing this. So we're going to, the next button after simulation is terrain foot planting. So I'm going to click on this, and I already had the terrain object selected, and so it added that over here. So for those of you who didn't catch what I did here, I had the terrain object selected when I clicked on terrain foot planting, and it just went ahead and added it to the simulation. If you have nothing selected, you'll get a little prompt at the bottom that says, select a terrain object and click enter. In my case, I already had it selected. So we could come over here and play forward, and we have terrain adaptation. The agents are moving with the ground, but foot locking is not enabled. So we can turn on foot locking very easily over here on the crowd solver. The crowd solver is what does the work. It's what does the simulation. I'll get into some more details and kind of flesh out in the next video. I'll explain in a more detailed way what all of these nodes do, so you have a little bit of context. But for the time being, just follow along, and we'll talk about terrain adaptation. So we're going to turn on, in addition to, we have this SOP object, which is the terrain we want to project on. So the script that's being run when you click on terrain foot planting here, it's one of the things it's doing is it's filling in this parameter. I'm going to turn on foot locking, and you can see, I'm going to come in here to one of these agents. If I turn this on and off, you can see it's doing something. So that foot kind of snaps to the ground. I'm also going to turn on show guide geometry. This is super handy. It allows, I just generally just leave this on. It lets me know when the feet are locked to the ground and when they're not. So it's super useful. There's also this control for adjusting hips, which I like to turn on. This is handy for if the ground is uneven and kind of like this direction, one hip will drop and the hips will adjust kind of the terrain. So yeah, handy for that as well. So, and those are generally like the settings that I turn on when I'm using terrain adaptation. So in addition to kind of clicking the terrain foot planting option, I also like to click on the enable foot locking, adjust hips, and show guide geometry. All right, so let's just play forward and we can kind of see this guide geometry for the foot locking doing its thing. So, and we can kind of verify that foot locking is working. Okay, great. So this is, pop back out. This is, we've set it to simulation and we got that working. We're going to do it, that's kind of going to be the end of this segment. In the next video, I'm going to talk a little bit about the actual construction of this DOPNet and what everything means. And we'll also, I'll just talk about DOPS in general philosophically and how it differs from the SOP context, which is you're probably already familiar with, to give you a little bit of explanation and also just a bit more comfort working in DOPS.